All right, so real quick, I want to walk you through Tinkercad, how to log in, and just the real basics of how you manipulate Tinkercad. So I'm assuming that you've gone in, you've looked through the instructions, you've watched about the design briefs, decision matrix, and you've probably made your decision on which one you're going to do. So if you open up the instructions, you'll notice that you have a class link right here, tinkercad.com/join class with a long string of numbers. And the information for your login is right below it. So it's going to be your last name plus the phrase AR20F at the end of it. So I'm going to go ahead, I'm going to copy this link and I'm going to jump over to that link. I'm going to show you exactly what happens. So it comes up with this screen, the WJHS Automation Robotics Fall 2020 class. Type your nickname. For me, I'm just a generic student. So generic student AR20F, that's me. And it'll let you in. So this is the Tinkercad intro page and sort of the how to look around. So what you're going to be doing when you want to design your problem is that you're going to create a new design, and it opens up this. This is the workspace or the work plane for Tinkercad. Get my face out of the way. So this is where you'll actually be doing your designing. Now there are a few things to know right off the bat. Number one is that you can change the size of this work plane. If you go back to your criteria and constraints in the actual assignment, it gives you a maximum size. And it's usually really easy if you just change your workspace to that size. So to do that, we'll come down here to edit grid, and it's in units for millimeters, and it says, hey, what size? So you'll adjust the length and the width to match the size that you're working with, which in this case is, I believe, 90 by 90, I believe is what it is. So obviously the work plane looks a lot smaller, but if I'm scrolling up with my mouse, it actually just zooms right back in. Not a big deal. So how does Tinkercad work? It is a 3D modeling program. So I've got my mouse. I'm going to start out, I'm going to right click and then start moving my mouse. So when I right click and move my mouse, it changes my orientation. And you'll notice in the upper left here, there's a cube that rotates along with it. That's your view cube. It's sort of where the camera is compared to the workspace itself. And I can actually come up here, I can grab that and rotate it however I want. And you'll notice as I move my mouse over that, it highlights these blue areas. And if I just left click, it'll automatically rotate my work plane to that orientation. So that's how you sort of look around at your model. And again, you can zoom in and out with your scroll wheel, or using the two-finger motion on your Chromebook. Okay, the home button takes you back to the home view. Okay, next up, fit all in plane. If you have a whole bunch of stuff in here, you can click that box and it's going to zoom it to the correct size. And then you have zoom in, zoom out. So zoom out, zoom in, and then orthographic versus perspective view. So orthographic is a flat view. It's like looking straight down. You don't see the 3D dimensions. Perspective view is actually sort of looking at it at an angle, and you can see all three dimensions of an object. So let's talk about those objects. So over here on the right-hand side, you have all of your objects that you can build with, and it starts out with just basic shapes. So for example, you've got box and cylinder with this sort of weird gray slashes, and we'll look at those in just a second, but we'll dive down. All these solid ones are basic shapes that you can build with. So I'm going to grab and just left click, drag, and let go, and I have a box out here on my field now. And I've gotten some options to go with that. So I click off of it and everything disappears. If I left click on it again, I get all my options. So looking at it from an angle, you notice it's got all these different options. So the first thing I'm gonna do is I'm gonna come down, I'm gonna click one of these white squares or anchor points. If I click on it, it allows me to access these, which is the length and width of the object. So maybe I want it to be 30 millimeters tall by just 15 millimeters wide. I can just change those numbers by typing on my keyboard. The same thing will happen if I click on this. This is the height adjuster. So perhaps I need it to be 25 millimeters tall. Now these are all millimeters because when we looked at our grid, we were measuring in millimeters. Now, this little black arrow, and I'm going to try and zoom in a little here, but this little black arrow that's on top of the height anchor is actually allows you to adjust where it is off of the work surface, either above it or below it. And once I've moved that once, I can now change it. Well, maybe I need it to be negative 15 below, or I need it to be 23 above the surface, or I want it right on the surface, just a 0. So that's how you manipulate how tall, or excuse me, not how tall, but how high above or below the work surface an object is. The next things that you can see if you look at this object, you've got these 3 little curved arrows, and these are the rotation options. So if I click and drag while I'm inside this hash marked circle, it's going to jump by units of 5 degrees, roughly. Not, excuse me, it's not 5 degrees, it's 22.5 degrees each time. So it's divided this into a circle based on that 22.5 degree mark. If I move my mouse outside of that area, I can now adjust it perfectly by individual degrees. And I can always say, well, maybe I want it to be negative 23.5 degrees, and it'll make that adjustment. You can do that with all of your different values, and each of them rotates the object in a different plane, so the X, Y, and Z planes. So now I've got this oddball little shape that's just sort of sitting. And we can add whatever we want to it. So for perhaps we need a cylinder that's sort of above the surface, but it's also really, really skinny. So it's maybe 10 by 10. And so we've got this. We can sort of move this around however we want using our mouse. We can move around and sort of see how they line up. Okay. But let's say what I really need to do is I need to cut a hole in this object. So I'm going to take this and I'm going to make this one really tall. And I'm going to lower it down a little bit. Maybe I'm going to make it a little bit taller. I'm just clicking and dragging. And I want that hole to be right there. So you notice I've got this cylinder going through my object, and I want to turn that into a hole. Up here in my options panel, you'll notice that right now it's on solid. So it's got this solid color. And then to the right is that gray hash pattern that we saw earlier when we looked at these basic shapes. And it says hole. So when I click that, it changes this object from a solid object to a negative space. Basically, it's a cutting tool now. It's a hole in whatever object there is. So I can now sort of see that, well, it's gray, but I can't see through my object. It's not really what I want yet. So now what we need to do is actually group these together. So I'm going to select them both by just clicking and dragging. They're both selected now. I can move them around together. I can change their heights together. Okay. But what I'm going to do is I'm going to come up here to the upper options, and I've got an option called group. And when you group 2 items and one of them is a hole, that hole cuts out from the other shape. Okay. So now that shape is gone, and I have a hole through my solid object. Now, what's really nice about this is that if I come back, select that object, come back up here to the top, the second option is ungroup. And if I click ungroup, it undoes it. And I now have 2 separate options. So maybe I decide that what I really needed was for this object to be over here to the side when I group them. And I can redo that. And I still have that hole cut through. Now, this happens with a hole when you group them. But for example, if I bring in another object, this sphere here, and I decide, well, I need this sphere to be right here. It's touching. I need those to connect. While this is a solid object and this is a solid object, if I select them both again and group them, they just add together. So it's a union of 2 objects rather than removing one object from another. So I can manipulate these individually and I can build complex shapes using these simple shapes. So most of the work you're going to be doing will probably use boxes and cylinders and spheres. There are some cones and triangular shapes. Rounded roof, you can do text if you need to. So for example, if I just open that up, I've got text. And now up here in my panel, I can say, well, maybe I need it to say WJHS. What font do I want it? There aren't a whole lot of options, but you can use whatever you need to for this. You'll also notice it's also got the ability to change the height in there. Segments has to do with how smooth the curves are on an object. For example, if I come back, I'm going to ungroup this. If I grab my sphere, the steps or segments, the more I increase them, The more I decrease them, you can see that the quality of the shape changes. So a really low number of steps or segments gets you a very poor quality sphere, whereas a high of a number gets you a much better version of a sphere. Bevel, you can sort of see it's changing how the shape is built. It's not quite as obvious on here as it is with, for example, a simple box, which again does not have a bevel option. It does have a radius option though, which curves your edges. So there are a lot of things you can do in this with the basic tools that they have around. And there are all these different shapes that you can use to combine together to build complex shapes. And that's the hard thing, is figuring out how can you take the complex item you want to build and break it down into these simple shapes that you then sort of combine and mash together. But what's really nice is that in addition to basic shapes, there are also some different things that you can use. There are more text and numbers. The shape generators are actually really cool. So I'm going to jump over to shape generators. I'm just going to go to the featured ones. So these are specialty shapes. For example, here is a thread. So this is like the end of a screw, and I can make it tall. And you notice it distorts those threads. And if we wanted something to thread, they have to be perfect. So we can come over here and make those adjustments. So what do we want the pitch of our screw to be? What do we want the diameter to be? How many segments on the tip? Should it be a smooth or a hard one? The scale of the thread. How many rotations should that thread occur on? Okay, so there's lots of things you can do with these fancy shape generators. For example, here is if you remember the fidget spinners from a few years ago, here is a real basic pre-built fidget spinner that you can modify for what you're wanting to do. Okay. But again, these pre-built options give you, again, a different way to build complex shapes. Now, as for how we use this with the rest of the work and what you're going to actually have to turn in. So to turn stuff in for this, you're going to actually have to submit a file. So I'm going to come back here and I'm going to go to my home view. So let's say that this WJHS is what I'm going to actually have to turn in. So in order to turn this in, what I need is what's called an STL file, or stereolithography. It's the fancy name for a 3D printable file that we can use on a 3D shape, whether it's a 3D printer or a CNC machine. It's basically the computer code that tells a machine, how do you construct this layer by layer? And so what we'll do is we'll select what we care about. So in this case, WJHS, and we're going to come up here to export. So under export, there are a few different objects. So I want just the selected shape in this case, and I want an STL. And if I click STL down here, it has downloaded that to my computer. Now, if you're on a Chromebook, it's going to put it straight in your drive, so you have to locate that. And you'll notice it's got this odd name, Surprising Jagoob. Okay, every name is going to be different. It assigns a unique name to every project that gets opened. So one thing you can do is come up here to the top and change the name. For example, the best thing would be to put your last name and then 3D printing design project. Okay, that way it's got your name and what it is. So that way when it comes to grading, it's real easy for us to look at and grade this when we get it into class. So those are the basics of Tinkercad, and that's super basics. There's so many things you can do with this program and actually build really complex, neat shapes that you can 3D print on your own or just designed to have. And there's lots of things you can do with it long term. There's an extra video over in Google Classroom for you to look at that gives you a lot more in depth, but this just gives you the real basics because it's all about simple shapes. So coming back here, these basic shapes, it's all about taking simple shapes and then combining them in such a way using the group feature that you get a complex shape, and then removing what you don't care about. For example, this is the scribble feature. I've designed my own little scribble there. and I want it to be a negative space. So select it all, group it again. And once again, you can get some incredibly detailed designs if you just take your time and work through it. But that's the absolute basics of Tinkercad for you to use on your 3D printing design project.